So, good afternoon, everyone. I am reporter number 36 and I am Christine Marialty MANON-OG. So, for today, I will be discussing about transportation evaluation, capacity, and level of service of highway segment in two-lane highways. So, capacity level and service. So capacity analysis involves the quantitative evaluation of the capability of a road section to carry traffic, and it uses a set of procedures to determine the maximum flow of traffic that a given section of highway will carry under prevailing roadway traffic and control conditions. So it also measures quality of flow, and it has a level of service, which is LOS, a qualitative measure ranging from A to F. So this chapter presents procedures for determining the level of service on, which is the two-lane, multi-lane highways and freeways. So for in my topic, we'll be focusing in two-lane. And also we are going to discuss the level of service from A to F. So here are the example or the typical or an image of a typical two-lane in a two-way highway in a rural environment. Next is the two-lane highway. So the procedures developed for two-lane highways segments provide the basis to evaluate level of service and capacity. So there are two types, which is the operational and the planning application. So in planning application, it uses estimates and default values in calculation. It also two classes of two-lane highways are analyzed, which is the class one means primary arterials, daily commuter routes, and links to other arterial highways. Travel will be at relatively high speed, and the class two is travel speeds will be lower than for a class one roads. Operational applications at an operational level of analysis, level of service is determined based on existing traffic conditions or future traffic conditions and specific roadway characteristics. So the highway capacity manual or HCM is procedure is designed to analyze two-lane highway segments for the two-way traffic for a specification direction or for a directional segment with a passing lane. So there are two types of measures used to describe the service quality of a two-lane highway. These are the PTSF and the ATSF. So the PTSF is the percent time following another vehicle, while the ATS is the average travel speed. So PTSF, the percent time spent following another vehicle, is the average percentage of time that vehicles are traveling behind slower vehicles. When headway is um, less than 3 seconds, the trailing vehicle is considered to be following the led vehicle. So PTSF is a measure of the quality of service provided by the highway. So average travel speed or ATS is the mean speed of vehicles in the traffic stream. So ATS, or in other words, ATS is a measure of the degree of providing efficient mobility. So though there are very big difference between the PTSF and ATSF. So LOS, or level of service, expresses the performance of a highway at traffic volume less than capacity. So LOS for class 1 highway is based on two measures, which is the PTSF and ATSF. However, in class 2, level of service highway is based on single measures only, which is the PTSF. Next one is the level of service criteria are applied to travel during the peak 15 minutes of travel and on highway segments of significant length. Level of service designations are from A, which is the highest, and to F, which is the lowest. So in the level of service A, it consists of the highest quality of service, desired speed, passing other vehicles, and then few, if any, platoons of 3 or more cars. So class 1, highway average travel speed is 88 kilometers per hour or 55 miles per hour or greater, and travel delays PTSF occur no more than 35% of the time. So class 2, highway maximum delay PTSF is 40% of the time. Maximum service flow rate or two-way under base condition is 490 PC per hour. So analysis of two-lane roads for two-way segment is usually performed on extended lengths at least 2.0 miles or 3.2 kilometers, and the segment is located in level or rolling terrain. Level 1 terrain flat grades of 2% or less. Heavy vehicles maintain the same speed as passenger cars. Number 2, rolling terrain short or medium length grade of 4% or less. Heavy truck speeds are lower than passenger cars but are not at the cruise speed. If the grade is greater than 4%, it must be analyzed using the specific grade procedure for directional segments. So here are the formulas used in calculating the value of PTSF of a two-lane, two-way segment. The base person time spent of the following, and which is VP is equals to V over PHF times FG and times FHG. So you can see all the description of the variables stated in that formula. So here are my one example for this topic. Computing the value of percent time spent following or the FPTSF for a two-way or two-lane highway. Determine the value of PTSF for a 9.6 kilometers two-lane highway in rolling terrain. Traffic data are as follows. So the data are already given. So volume, percent trucks, percent RDS, peak or factors, percent directional split, percent to passing zone. So for the step 1 in solving the problem, compute first the peak or the 15 minutes early passenger scan equivalent or the VP. So trail value for VP is V over PHF, which is the 1,600 over 0.95, and the answer is 1,684 PC per hour. So determine FG, which is it's already in table 9.4, and determine ET, which is also in table 9.5. So the formula FHV equals to 1 over 1 plus PT ET minus 1 times P times to the quantity of ER minus 1. So by substituting the values in the formula, we can get the value of VP, which is 1,684. So the step 2 is compute the base percent time spent following, which is the BPTSF. So you can see the next one is the step 3, compute percent time spent following. Next one, here is the table for the adjustment for combined effect of directional distribution of traffic and percentage of no passing zone on percent time spent following on two-way segment. Here is a table 9.3 interpolation, increase in PTSF in percent, so the no passing zone. So next one is calculating the value of ATS for two-way segments. The average travel speed for two-way segment is completed using the 9.5 table. So here are the 9.5, so which is the formula given in that figure, which is the ATS equals to FFS minus 0.0125 VP minus FNP. So here are the description for the variables stated in the formula. Next one is determination of free flow speed. Can be completed in 3 ways. First is field measurements at volume, and the indirect estimation when field data are unavailable. and they're also given formula. So that will be all. Thank you.